Hey guys, what's up? So in the last video I talked about the if-else statement, so this time I'm going to talk about a concept that's really similar called switch statements. So what's the difference between an if-else statement and a switch statement really? In theory, the switch statement can be used instead of an if-else statement to do some low-level optimization, due to the fact that switch statements could be more easily translated into a jump table, which is basically a way computers move across to a different part of a program. But really in practice, that isn't too relevant to us, and really the switch statement can just be used as an alternative to the if-else depending on which structure you like better. Overall, I prefer the if-else statements, and so most conditionals in my videos would be around that. However, since switch statements are a major part of programming, and can be better than if-else in certain situations, such as when there are more possible conditions, I will introduce them as well. So while if statements revolve around a structure of multiple need-to-be-satisfied conditions and statements in those conditions, switch statements revolve around a value and compares it to some possible cases. Switch statements go quite deep, and many things include concepts not yet taught in this course. So today I'll just go over the basic functions of switch statements. How switch is different than other languages, interval matching, value binding, and the where key term. So before you learn all that, let's first open up Xcode. I'm just going to open up a playground. Alright, so the basic structure of a switch statement is that you give the switch statement some value to consider, and then you have a bunch of cases where the value equals something, and in each case you do something. That may sound a little bit confusing, so let me just give a quick example. I'm going to define a constant called number, and it's going to be an integer, and I'm going to initialize it with a value of 5. To do a switch statement, you first type switch, and then number. So number is going to ultimately be the value that we want to consider. Great. Next, we do case 1, for example. So case 1 would basically cover the case where if number equals to 1, what do you do? So you end it with a colon, and you just start typing. So print the number is 1. Cool. Next, we can do case 2. And we can print the number is 2. Next, we'll do case 3 when number equals 3. So the number is 3. And we can keep going. Alright. So we have covered 5 cases, each case representing a value that number could be and what to do if number is that value. But we're not done. An error pops up and says, switch must be exhaustive. Consider adding a default clause. So what this means is that switch statements should always have some kind of default case, because they're what we call exhaustive, meaning that you need to provide a case for every possible value of the value. So in this case, we've only provided 5 cases, but in fact, number could be any integer really. So we have to provide cases for every single number. But what happens if you just don't have that time? Then you do a default case, which you do by saying default, and then you can say print other number. So what default is more or less like an else. If it's not covered in any of your cases, then it defaults to the default statement. So if, let's just say number was 6, and none of the cases cover 6, then the default case will execute and other number will print. Let's just say instead that number isn't actually an integer, and we have a boolean. So I'm going to say is true is a boolean, and I'm going to call it false. And so we can actually cover all the cases for boolean because there's only 2 possible values. So I can say case true, and I can say print it is true, and I can have a case false where I can print it is false. And there you go, we have all of our, sorry, let me change this up to is true. So we have all of our cases covered, and there is no error. However, it's always a good idea, just out of habit, to put a default case anyway. Even though you don't need to, you can just say print something went wrong. It's always a good idea to do it, even if you don't need it. So another thing that we have to know is that switch statements in Swift are a little bit different from the switch statements that you may be used to from languages like C. In a language like C, the switch statement has to go through all the cases. Even if one of the cases was already satisfied, the program will still go through the rest of the cases, regardless. However, in Swift, the switch statement only runs its execution until it finds a case that matches. Then, it just breaks out of the switch. As I said before, in C or other languages, the Swift just falls through all the cases regardless, which can result in a possible execution of more than one case, and that's not that safe. So Swift has you covered there, where there is no implicit fall through, and immediately when a case is satisfied and executed, it breaks out of the switch statement. Lastly, there's one basic thing that I want to cover about switch, and it's basically just saying you can't have an empty case. So let's just say that I have a case 1 that is empty. An error pops up and it says case label in switch should have at least one executable. So you can just put in break, which basically means if it's case 1, do nothing and break out of the switch. Now, all the stuff that we've covered so far have been pretty basic in terms of what values and what cases we can have. In switch statements, we can actually have more than one value per case. Let's do an example. I'm going to define some string called SomeString as a string, and I'm going to make it a letter. So let's just say that I make it the letter E. Then, using switch, SomeString, I want to do something different if it's a vowel, and I want to do something if it is a consonant. So, what I will do is case A, comma E, comma I, comma O, comma U. So what this means is that if SomeString is A, E, I, O, or U, then it does this case. So I'm going to say print SomeString is a vowel. Great. Okay, next I want to see if it's a consonant. So I'll just say case B, C, D. Y, and Z. So this case would cover all the consonants, and I would simply print SomeString is a consonant. Alright, so now we have our two cases. Now we want to provide a default case, because it's possible that SomeString won't in fact be any letter in the alphabet, and it could be some sort of symbol. So default, I'm just going to print this isn't a letter. Awesome. So as you can see, the output is E is a vowel. If you do something for A, it prints A is a vowel. And let's say we have a consonant N, and it says N is a consonant. And let's just say that we have some kind of symbol. So not a letter, I'm going to put an asterisk, and it says this isn't a letter. So we can tell that with switch, we can actually put in multiple values per case, and it'll still work out. This is just the very basics of switch. In fact, you can do a lot more with it. Instead of comparing value for value, for example, having a single value compared to another value, you can actually have a range compared to another value. For example, if I have a case 1 through 10, I can check if the number involved is 1 through 10. I'm going to do a quick example that shows range. So I'm going to define a constant called number. It's going to be an integer, and it's going to be 43. Then I'm going to have a switch number. Cool. So first I'm just going to have a regular case, case 0, and I'm going to say print the number is 0. Then I'm going to have a case 1 dot dot less than 5 colon. So this is a format that you've never seen before, and this dot dot less than is actually called a range operator. So what I used here is something called a half open range operator, which basically means For a case where 1 to 5, not including 5, then do something. If I want to include 5, then I can use a closed range operator, which is just 3 dots. So case 1 dot 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 5, you do something. So anything from 1 through 5, I want to do something. But in this case, I just want a half open range operator. So from 1 to 5, not including 5. So I'm just going to print number is less than 5. I can have another one, case 5 dot dot less than 20, and we can do the same thing. Number is greater than 5 but less than 20. And finally we can have a last case where it's 20 dot dot 100, and we can say print number is greater than 20 but less than 100. And then finally we're going to have a default, and we're just going to say print number is out of range. So let's see what prints. Number is greater than 20 but less than 100. As you can see, since 43 is in the range 20 to 100, not including 100, then it prints number is greater than 20 but less than 100. Let's just mess around with this and just look at the edges, right? So I'm just going to make number equal to 100. What's going to happen? Number is out of range because, as I said again, this is a half open operator, meaning that 100 is not included. If I were to put 3 dots, then 100 would be included and it would print number is greater than 20 but less than 100. Awesome. So that's just interval matching. Next, another concept that's really important to switch is something called value binding, which means that you can bind a value to temporary constants or variables. So let's do that. So first I'm just going to define a constant called number. I'm going to make it an integer and make it equal to 2. Then I'm going to write a switch number and say case let x print x. So what prints is 2. Now this may be kind of strange, but what happened is that in this case it let x equal to what number is. And so essentially number plugs into x, and so we print out x. You can use this in a lot of different situations, and it's pretty useful if you want to have tuples. So I'm just going to define a tuple, and if you don't know what a tuple is, it's basically just a grouping of values. So I'm going to have a tuple called 2, 3, and let me make switch tuple, and then have case let x 0, and I'm going to say on the x-axis with an x value of this. Next I have case 0 let y, where it's going to print on the y-axis with a y value of y. And finally I'm going to print case let x y, and then print somewhere else at, and so what prints is somewhere else at 2, 3. Now this may seem a little bit strange, but if you look at it closely, it's really no different from anything else besides for the assigning of values. So the first case assigned 2 to x, and then the second part of the case checked if the second value of the tuple equal to 0, and it didn't, so it went on to the next case. So in the second case, this case checks if the first value is equal to 0, and then it assigns 3 to y, and obviously that wasn't true. So lastly, what happened was that it assigned the tuple and printed it out. So that is value binding, and that is actually very, very important in Swift, and we're going to use it a lot in the future. The last part that I want to get to is using the where keyword. So what where is essentially it introduces additional conditions. So in addition to another one, you also want to have a where. So it's almost comparable to the AND logical operator. I'm going to define another tuple and I'm going to make it equal to 1, -1. Then I'm going to have switch tuple case let x, y, where x equals to y. And then I can print is on the line x equals y. Cool. Next, I can have a case let x, y, where x equals to -y. And then I can say, I'll just copy and paste, print this is actually on the line -x equals to y. And finally, then I'm going to print simply case let tuple x, y. And then I'm just going to print this is on some other point. And what shows here is 1, -1 is on the line -x equals to y. So let's look at what this means. First, the case assigns the x and y values according to the first and second values of tuple. And then it wants to check if x equals to y. And the same happens in the second case where it checks if x equals to -y. And so this where essentially introduces a second conditional that needs to be met in order for this case to happen. Since Swift is really cool in the fact that it doesn't fall through and go through all the cases once one is true, what happens in this code is, first, it realizes that x does not equal to y, so it goes to the next case. Then, it finds that x equals to -y, so this is true. So, since Swift just breaks out of the switch after a single case is met, this case let xy is actually never executed, which is really helpful because if it was in C, both of these statements would be executed, due to the fact that C switch statements would just fall through all the cases regardless of if any of them were true. Great. So, let's just have a quick final review of what we learned in this video. First, we learned that while there are some marginal differences between if-else and switch statements, really, as a beginner developer, you can really use them to your own preferences. Second, we learned the structure of the switch statement and how we can actually use multiple values per case. Then, we talked about interval matching, and we talked about the range operators, the half-open range operator and the closed range operator. We talked about value binding, where you can temporarily bind a value to a constant or variable to use in a case. And finally, we talked about the where keyword, which checks for additional conditions. I hope you learned a lot in this video. Thanks.